Well, here it is, the Mosley TA-33-JR work, the Warrior. 15 years in operation, almost 15 years. Over 1,000 band slots I worked with this antenna. In October of 2022, I replaced my Mosley TA-33-JR with the Mosley MP33NW, as I had fried the traps on the TA-33-JR. Totally my fault, by the way. The TA-33-JR was left in pieces as the traps were shot, and a few of the aluminum sections were unusable as well, as I had not properly applied Penetrox to them back when it was installed in 2007. I kept the salvageable sections stored in a box in my garage, thinking there could be a sort of aluminum resurrection someday, perhaps in the form of a 6-meter antenna. Well, that day is today. In June of 2023, I built and installed a 2-element PVC Moxon for 6 meters. It worked well enough, but in the background you can see the looming problem, and that manifested itself in November of 2024 when a long branch got caught in one of the wire elements. I repaired it easily enough, but felt this was a likely reoccurring problem, and I wanted a better solution. By the way, this is why I don't have a hex beam at my QTH. I've been quite pleased with my M² 6 Mic 3 and considered buying another one to replace the Moxon. Then I thought, wait a minute, I've got those old Mosley TA-33-JR parts just sitting in my garage. Why can't I Frankenstein those into a 6-meter beam? And just like that, I'm off to the races. My plan was to style a lightweight 3-element 6-meter Yagi, which consists of these 4 elements: a director, a driven element, and a reflector, all supported by the 4th element, a crosswise boom. For direction on the lengths of each, I went to the YouTube channel of Stan Gibilisco, now with Silent Key, and came up with 101.6 inches for the director, 112.3 inches total length for the driven elements, which is actually 2 sections divided at the feed point, and 122 inches for the reflector. The boom was preset at 72 inches, as that was the longest section of tubing I had. For those of you who watched my Mosley MP33NW build video, this box should look familiar. In this are the old TA-33-JR aluminum tubes and hardware. Since these tubes were up in the air for 15 years, there's quite a bit of grime on them. It was tempting to use a corrosive chemical to remove said grime, but the internet said if I did that, I could harm the aluminum. So I'm using dish soap, water, and a scrubbing pad. I'm not going to show you the cleaning process for very obvious reasons. Oh well, what the hell. I'd say overall, considering they're 17 years old and we're outside for 15 of those 17 years, these cleaned up real nice. That'll be good. Let's go over the elements I will be using to make the Frankensteined 6 Mic 33-JR. I'll start first with the boom, and this is 72 inches long and 1.25 inches inside diameter. And what you didn't see off camera is when I was taking that section out of the box, it was at kind of a weird angle and ended up smacking into this. Very lucky that didn't shatter. Next we have the director, and this is actually the center section of the reflector from the TA-33-JR. It's 72 inches long and 5/8 of an inch inside diameter. That's not going to be long enough at 72 inches for a director on a 6-meter beam, so I'm bringing in this piece, which was originally used on the TA-33-JR as a reflector piece, and this is 40 inches long and 1/2 inch inside diameter. Moving on to the driven element, we're going to be using the original center section of the reflector from the TA-33-JR, and this aluminum piece, also 72 inches long and 3/4 of an inch in diameter. And the inside is one of the pieces from the reflector. This is 72 inches long and 5/8 of an inch inside diameter. To support the driven element, or I should say driven elements, because that center section is going to be cut in half, I'm going to use the same center support bar that Mosley had on the TA-33-JR. To complete the antenna, we have the reflector, and I'm going to be using a reflector element from the original TA-33-JR. And this is a 72-inch piece of aluminum tubing, 5/8 of an inch inside diameter. It's going to require 2 drill holes at the center because I'm going to make this a center section. And inside of that will go this 72-inch 1/2 inch in diameter section that was originally found on the director. This will be cut down substantially because it doesn't need to be 72 inches. In case you were wondering, yes, there's a pillow down there for support because my knees aren't 21 anymore. Ha! Let's begin the build, and I'm going to start with the director since it's the easiest of the 3 elements. And we have the center section right here with the mounting holes already drilled into it since it came that way from Mosley. And I need to cut this smaller section in half so we can get the proper length, or the desired length rather, for the director. And I'm just going to use a hacksaw. What's wrong with that? As discussed earlier, the target length for the director is 8.47 feet or 101.64 inches. And these end sections that I just cut go into the center section and stick out about 14 3/4 of an inch. And I can always adjust that length when testing. In the spirit of KB5 MIQ Big Boy, who often talks about doing things on a budget, I'm not going to go out and buy hose clamps to secure these tubes together. Instead, I'll just use sheet metal screws, which I already have here. That said, for testing, I will secure these 2 sections by using electrical tape. Now, you know I'm a big fan of Penetrox, and here it is. For any final antenna installation, I strongly suggest Penetrox or some sort of anti-seizing compound to go in between each sections of aluminum tubing. So long as I'm down here, I might as well check continuity. Just like that, the director's done. The process to build the reflector is underway. I've already cut the end sections in half and they turned out just fine, but there's an issue. The center section of the reflector doesn't have the holes in them to mount them to the boom. Notice this is the driven element center section, and the director center section did have those holes pre-drilled, but the reflector does not, so I'm going to have to drill those manually. I don't have a drill press, so I'll just do the best I can. This is about as redneck as it gets. The driven element center section is 1 size larger than the reflector center section, so I slid the reflector center section inside of the driven element center section. That's going to give me obviously a perfect drilling template. Well, it wasn't easy, but gosh, it's perfect. That old Black & Decker makes this look like it was done by a champ. Drill, baby, drill, baby, drill. The length of my reflector will be 10.16 feet or 122 inches. The center section is already 72 inches, so I need another 25 inches on each side, and that's what these extension tubes will provide. Here's the reflector, and it's all set to go. The driven element's going to require some more hacksaw work. I need to cut both of these tubes in half. The inner tube here needs to be cut in half so it'll fit inside the center sections, and the center sections need to be cut in half so there is an inside and outside conductor from the coax at the feed point. There goes an eardrum or 2. Look at that cut though. Beautiful. What's the old saying? Measure twice, cut once? Ha! It's for sissies. So again, look at that cut. Now that the tubes have been cut for the driven element, let's see how I'm going to assemble it. The length for it will be 9.36 feet or a little over 112 inches. And how I get there is going to be a little tricky. Not difficult, but trickier than the director or the reflector. This is the center section that I cut in half. And 1/2 is going to go on this side of the support bar, and I'm going to have to drill a couple of extra holes to get it into these mounting blocks. It's going to meet at the center with the other half of the center section that I cut in half, and leaving about a 1/2 inch gap in between both elements so we can properly attach a feed point. Once that's secure, I just insert the outer tube for the driven element and make sure that the total length between the two is 9.36 feet, and I should be all set to go. I decided to put a crowbar in my wallet and go out and get some hose clamps. They're cheap, they don't weigh much, and they'll make adjusting the elements for the optimum SWR much easier. The negative is, it means I gotta hacksaw some slits into the aluminum. Every time I do that, they're crooked. I'm doing a single 1-inch slit on the center sections of the reflector, director, and driven element. I suppose I could do 2 slits and make them longer, but it's not as if I'm going to be playing tug of war with these things, so it should be fine. Here are the 2 center sections. This is the support bar, and this is going to be the feed point. I'm using 1/4-inch nuts and bolts simply because I have them available. Now the feed point's a little bit further apart than I'd like it to be. So what I'm going to do is hacksaw off a 1/2 inch on both center sections to draw these a little bit closer while still maintaining that 1/2 inch gap. There we go. Much better. The measurements are all set, but I have to drill more holes in the aluminum tubing of the driven elements because these plastic blocks that hold them in place are threaded, and there's a screw that goes through the aluminum tubing and into this, and that secures it. So what I'm going to do is I'm going to use this light above me almost as a laser guide to determine the center, drill through that, and do the same thing on the opposite side, and I should be close enough to be able to get the screw into the plastic block and keep them in place. The elements are secure. This side is perfect. This is pretty much exactly a 1/2 inch. They spelled my name wrong. The feed point is somewhere just over 1.25 inches apart. So the length of each side of the driven element should be 56 inches, and that's from the split here to the end of each element. The end tube sticks out about 21 inches past the center section. So here's the driven element, all set to go. It looks great, right? Well, there's some issues. For the hose clamps to work, the slit needed to be longer than 1 inch. I bet those watching me do this earlier in the video said, "That's got to be longer than that," and you were right. The other noteworthy issue is weight. We got to go on a diet, and just like with humans, we're going to start in the center. This support bar here was designed for 27-foot long elements. I'm going to cut that down significantly and move this plastic block maybe down to here. Two hours later. Just kidding, but it was some work. So now what I'm going to do is tape these two together and use this cut section as a drill guide. You know, the local hospital is going to be really happy when this project is over because every time I use power tools, they have to put extra personnel on standby. The shortened center support section is complete. I shaved 2/3 of the weight of this particular piece of aluminum, so we're one step closer to a 3-element beam. And what you did not know is that this was almost the 6M-22 Junior. Weight was such an issue that I briefly abandoned a 3-element Yagi in favor of a 2-element design, as you can see here being tested. However, I wanted the benefits of a 3-element design, so I took the steps necessary to reduce the weight of the antenna. This certainly has been a much more difficult project than I anticipated, but so far so good. I think it's going to be okay, and if it doesn't work, what have I lost? These are just spare aluminum tubes sitting in my garage from an old antenna that's no longer up, so I got nothing to lose. Might as well try. Time for the nasty stuff. I'm going to apply Penetrox to all tubular sections that join and to all bolts or screws. To attach both the director and reflector to the boom, I am using the same hardware used on the TA-33 Junior. That includes this metal clamping block, which is curved in such a way on 2 different directions that allows both the boom and the element itself to sit nice and snug, using this U-bolt and a couple of nuts. Here are the driven elements and the shortened support bar, and that's held on to the boom by 2 U-bolts, some nuts, and 1 plastic clamping block. Here's a look at the hairpin match I'm using for this antenna. I got the design from Kilowatt 1 Baker Quebec Tango in his article, Build the Featherweight 6-meter Yagi. It's made out of soft 8-gauge aluminum solid wire, which I easily bent into shape with the pliers. It's 5.5 inches long by 1.5 inches wide, and it attaches to both sides of the feed point. This is the center point of the boom right here. This is the mast plate that was used on the TA-33-JR. Heavy duty, thick, 11 inches long. If I put this in the center, about there, it's going to push the driven element much closer to the director than I want it. Didn't think I could cut this with a hacksaw, but I did. And there it is. It looks pretty good too. They're probably going to have to take me out of Monday night's playoff game against the Rams and put me on IR, but there we go. Now we got a real mast plate on here. Look at that 1/4 inch thick aluminum. Almost forgot that I had these 1.25 inch caps left over, and these can go on either end of the boom. Now these aren't the crappy ones that Mosley gives you that fall off after 3 months. These will last many, many years. They fit beautifully too. Alright, after clearing my driveway and 2 neighbors' driveways of snow, we didn't get that much, but nevertheless, here I am testing the antenna. You can't even make this stuff up. The SWR curve and dip were just on the real high side of 6 meters. I had to adjust the length of the director and the driven element. I just kept lengthening them both in small amounts on each side of the center and eventually obtained this, which I'm very pleased with. The reflector really didn't make much of a difference. When I moved the reflector elements, it didn't change much. Here are the revised element measurements for the 6M-33-JR. It's a real sharp cue though, sharper than I expected, but still plenty of bandwidth there for the DXing side of 6 meters. The hairpin match was very important. Without it, the SWR was like 2 to 1 everywhere. One thing I see in a lot of instructions is they attach the hairpin to the boom. I found that that made 0 difference. I ran a jumper between here and the boom, and no difference whatsoever. Now I know the SWR curve and dip is going to change when I get it in the air, but that's okay. I'll just lower it and make the adjustments needed. That's easy. I mean, aside from my hands being a little chilly, this worked out real well. So we're just about ready to get a 3-element beam fully done and hoist it in the air and see how it performs. Let me interrupt this Frankenstein antenna video to explain something important about good SWR. What does it mean? It tells you you have an excellent relationship between your antenna, your feed line, and your radio, but it does not guarantee that you have an effective radiating antenna. Remember, a dummy load is a flat match on all bands. Feed line choke time. Going to use 2 pieces of PVC. Put a SO239 on here. LMR 400 or RG213. I can't remember the coax that'll be going to this end. Inside I'll be using RG8X because thinner coax apparently is better for a feed line choke than thicker coax. Cut a hole for that here. Put those 2 together. Put some tape around it and should be all set. Now that the SO239 is mounted, I need to matriculate this RG8X into place and get it soldered. I keep hearing that white petroleum jelly works really well at keeping the water away from your connections, so I'm going to try some of that. Packing some petroleum jelly in here now. I also applied silicone to the SO239 and to the end where the RG8X is, and that should help prevent water ingress. So now we wait for this to set. The choke itself will be an air wound design using RG8X coaxial cable. Just going to make sure these solder lugs fit the feed point of the antenna before I solder them to the coax. Everything's sealed up. I even put a little bit of liquid tape on the end, so this should stay good for several years. And it's rather thick too. Keep in mind, this is RG8X coax. My one regret is the last time I was at the hardware store, I didn't get red electrical tape. It would be nice to have both red and black so I could tell the difference between the inner and outer conductors many years down the road, but too late now. Just doing some last minute testing on the 6M-33 Jr. and just ran an SWR sweep here, and it looks to be 1.5 to 1 or less across any sections of 6 meters that I will be using. This SWR curve is very similar to the M² 6M-3, so I'm very happy with these results. Note that I have a feedline choke now in place. It's late January and it's antenna raising day. First thing I'm going to do is add a feedline choke. If this was a more permanent installation, I would probably add some liquid tape onto the feed point here, but these are stainless steel nuts and bolts, so I think it'll be okay. The feedline choke is in place. I use mass trans support rope because the twist ties normally break after a short while, and there's a little bit of a gap between the choke and the boom, so that should be fine. Well, here's a real hardy soul. No jacket. What is it, 4 out right now?
Yeah, not for long.
All right, see ya.
It's 9 degrees in Fridley right now.
Time to lower the Row 9H50. I always wear gloves when I do this. In between the tubes, there's a little bit of a gap, and if your skin gets caught in there while you're lowering this, it's bad. I always make sure I have protective gloves on. They've saved me more than once. To loosen or tighten the L-bolts, I use a pliers, which is a lot better than just hand tightening it. I got that idea from David, KC6ZBE, who was real helpful with all my questions about the Row 9H50 push-up mass. I just got to make sure I don't crank on it too much, because otherwise it'll break. Well, the Moxon is down, and there are some parts I need off of it. I need this U-bolt here, and I also need these 2 clamping blocks. Right now I'm trying to get the plastic clamping blocks to line up with the U-bolts. It's not easy when your fingers start tingling because it's so cold, but I'm getting it. There's still 3 hours before football starts, so I've got time to get this done today. All right, she's mounted and she's solid. I still have about 5 minutes left. I might have enough time for a quick SWR check before lunch. Well, I'm gonna need a little bit of work on this. You may or may not be able to see it here. The SWR shape of the curve and dip is the same as it was when I had it in the testing position, but it's now well below the band. It's 1.1 to 1 at 49,630, so I'm going to have to shorten the driven element and maybe the director a ½ inch to 1 inch, but that's going to have to wait until after lunch. Let me hijack this video again for one brief moment, and since it's -1 Fahrenheit out here right now, I definitely want to make this brief. Why was there an SWR shift? The physical antenna itself did not change, but the SWR did. There was a change in environments. That antenna went from my front yard here in my driveway on a ladder to the backyard on a Row 9H50 push-up mass. Antennas see and more importantly feel everything around them. change the environment and you change the antenna. That's all there's to it. That's an important lesson for anyone who's installing an antenna, and I encourage those who are doing so to not be afraid to make modifications to better match the antenna to the environment. That said, don't wind up in a foobar situation. It's better to have a compromised antenna that works than a modified antenna that doesn't. After lunch, I began my adjustments, focusing just on the driven element to see if I could get the SWR curve to behave. I certainly was happy that I went with hose clamps to secure the elements versus sheet metal screws. Those would have required far more effort, whereas the hose clamps were significantly easier. As you can see, I'm reaching up and adjusting the driven element. I'm 6 foot, and the plastic containers I was using to give me some height were just not quite as tall as I would have liked, but nevertheless, I got the job done. And there's the dip. 5330, almost exactly on the FT8 frequency. Here are the final element measurements of the 6M-33 Junior. You're looking at 1.5 to 1 or better in almost the entire area of where I use 6 meters, so I ain't gonna touch it. Up she goes. Had to attach the coax to the feed line choke first, used some self-amalgamating tape in there, and wrapped it with some more electrical tape. That should be good. You might be wondering, why do I do this in the winter time? It's late January and it's cold out here. Well, Dawn, Whiskey X-Ray 0 Zulu, reminded me just last night that about a year ago we worked some really good DX on 6 meters in the winter time, so I'd rather have the antenna than not. Well, that looks like a 3-element 6-meter beam. I had to Z it, which meant putting this nail in there to keep it in place pointing to the north. Then I had to loosen this and then turn this until the director was facing straight north. I hereby christen thee the Mosley 6M-33 Jr. Well, it's not bad. I have to head inside and see if it works, but should have no issues there with the SWR curve that I saw at the feed point at the antenna, so we should be in good shape. As far as the Moxon is concerned, well, I'll keep it in the garage. It may be of some use someday. Well, now it's time to clean up and then, of course, warm up, and then I'm going to do some on-air tests to make sure the antenna is working at the shack.
The Eagles will be playing the Commanders at Lincoln Financial Field today at 2 p.m.
Oh gosh, I better get going. It's a few minutes before kickoff, so let's check that SWR. Beautiful. Now let's head up to the FT8 frequency. The band's dead. There's nobody on 6 meters right now. I'm actually going to go a little bit above it just to be safe, though. All right, let's check things out with the amp. All right, here we go. All right, a kilowatt, 1.2 to 1. I can live with that all day long. Well, this has certainly been a heck of a project. Starts out with a bunch of aluminum tubes sitting in my garage and ends up as a 6-meter beam. It might pay off someday too. I might be on 6 meters sometime and snag some new one because I took the time out to do this. But either way, it's been a lot of fun, and hopefully you've enjoyed this video of this Frankenstein project of the Mosley 6M-33 Jr. Thanks very much for watching in 73 from Whiskey X-Ray 0 Victoria.